Alright, today we're going to start day 2, which is the last day of notes for this unit. I know that's very exciting. Which is section 12.2. We're going to be talking about the law of cosines and Heron's formula. So we use the law of cosines when we have side, 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 or side, angle, side. And we use Heron's formula. It's another way to solve or to find the area of a triangle. And you use that when you have all three sides. Alright, so here we can see the law of cosines. Again, this is something you will need to know. We have this version here on the left. We use this if we have side, angle, side, or we're solving for a side. All three of these are the exact same thing. It just depends on which side you're solving for. And then over here on the right, this is when you have side, 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 and you're solving for an angle. Again, the left and the right are the same exact equation. It's just on the right-hand side, the equation is modified so that the angle is isolated. On the left-hand side, the equation is modified so that the side that you do not know is isolated. Okay, so now the next question you're saying to yourself is, alright, great, this is a lot of combinations of letters and trig functions. Prove it. So here I have this triangle ABC and sides ABC as well. And if we show the altitude of this triangle, I'm going to call the altitude Y, and notice that I cut side A into segments X and A minus X. Now, if I look at this small right triangle here, I know that C squared is A minus X squared plus Y squared. Fantastic. Now if I look at the other right triangle over here, I know that the cosine of angle C is X over B, and I know that the sine of angle C is Y over B. Therefore I know X is B times cosine of C, Y is B times sine of C. Alright? Now if we do a little bit of substitution into this Pythagorean equation that we had up here, I know C squared is A minus, and remember it was X, but X is B times cosine of C, quantity squared, plus we had Y squared, but Y is B times C, or B times sine of C. So B times sine of C, quantity squared. Multiply this out on the left and we get A squared minus 2AB times the cosine of C, and then plus B squared cosine squared C plus B squared sine squared C. Factor out the B squared from this equation, or from these two terms, sorry, and we're left with cosine squared C plus sine squared C, which we know is 1. So now if I just rearrange this, I end up with A squared plus B squared, so that's right here, and then minus 2AB cosine C. So there is my law of cosines. And you could do that for, rearrange these letters, and you can show it for any angle. Alright, so now moving on to an example. So here we're given the side, side, side scenario. Side A is 55, side B is 25, side C is 72. We don't have units, so we'll just say units. So here's the thing. If you're going to use law of cosines to solve this entire problem, you do not have to worry about the hint that I'm showing here. If after you use the law of cosines, then you switch to using the law of sines because you'll have a side and an angle that correspond, then you have to do what I'm saying here. So that is find the largest angle first. How do we know what the largest angle is? It's opposite the largest side. Very good. So if you're going to switch from law of sines to law of cosines within the solving process, you need to find the largest angle first, otherwise there's the potential of creating what I'm going to call a false triangle. If you just use the law of cosines the entire time, you're fine and you don't have to worry about that. So I want you to pause the video, solve this triangle, which means find the remaining three sides, unpause when you're ready to check your work. Okay, so I used law of cosines for all three angles here. You obviously don't have to do that. As soon as you have two angles, then you can subtract them from 180. That's the easiest method. But just to show you the work, that's why I chose to do this. So first I did find the largest angle, even though, again, because I continued to use law of cosines, I did not need to. So cosine of C is 55 squared plus 25 squared minus 72 squared over 2 times 55 times 25. So if I type that into my calculator correctly, the cosine of C is negative 0.558. Therefore, C is 123.905 degrees. Remember, always round to 3 decimal places at least. So real quick, one of the issues, or basically the biggest issue with law of cosines, is typing things into your calculator correctly. So I would recommend typing this entire thing into your calculator exactly as it's written, using parentheses in the numerator and denominator, and that will hopefully help you eliminate calculator errors. If you try to type it in piece by piece, that's probably where you're going to make a mistake. So to demonstrate what I'm talking about, I'm going to type that in. So I'm going to do parenthesis 55 squared plus 25 squared minus 72 squared, close the parenthesis, divided by parenthesis 2 times 55 times 25, close the parenthesis, hit enter. So there's my negative 0.558, and then cosine inverse of that answer. Hopefully I'm in degrees. I'm in radians, so I need to change that. Hit enter, and there's the 123.905 degrees. So again, type the entire thing in parentheses numerator, parentheses denominator, and you're good to go. Alright, so continuing to look at the rest of the answers. Cosine of b is 72 squared plus 55 squared minus 25 squared over 2 times 72 times 25. Type that entire thing in. Cosine of b is 0.958, so therefore b is 16.749 degrees. Again, from here you could just subtract these two angles from 180, but I chose to do law of cosines again just in case you had done cosine of a also, or earlier instead. So cosine of a is 25 squared plus 72 squared minus 55 squared over 2 times 25 times 72. Cosine of a is 0.773, so a is 39.346 degrees. Very nice. Next one. So here you're given the side angle side scenario. So here you're forced to find side C first. That's the only thing you can find in this case. However, from there, if you choose to use law of sines, now you want to find the next or the smallest remaining angle after you find, in this case, side C. If you continue with law of cosines, then you don't have to worry about that. But if you switch to law of sines, you want to find the smallest remaining angle after you find side C. So go ahead and pause the video and unpause it when you're ready to check your work. Okay, so here I found side C first, so I know c squared equals 6.25 squared plus 2.15 squared minus 2 times 6.25 times 2.15 times cosine of 15.25 degrees. That's 15 degrees, 15 minutes is 15.25 degrees. Type this all into your calculator exactly as it's written. Do not try to use parentheses anywhere. Do not try to group this into pieces. You will make a mistake. Let your calculator do the work for you with order of operations. It will do that correctly. So you get c squared is 17.756. Take the square root of both sides. C equals 4.214. Just to prove it to you, because I know this is something that's difficult with this section, type this in your calculator. So 6.25 squared plus 2.15 squared minus, I apologize for that timer, that just means my laundry is done. So back to this, minus 2 times 6.25 times 2.15 times the cosine of 15.25. Enter, and there we have 17.756, square root, second, answer, and we get our side. Okay, so from there, then I chose to continue with the law of cosines. Again, you could switch to law of sines, but I would have to consciously try to find the next smallest angle or the remaining smallest angle. I don't want to deal with that, so I'm just going to use law of cosines. I know I don't have to worry about those issues then. So if I use the law of cosines, I chose to find angle A. You could have found angle B just as well. So I end up with angle A is 157.02 degrees, and then I just subtracted from 180 to find angle B, which is 7.73 degrees. Moving on, word problems. So a plane flies 810 miles from Niagara to Cuyahoga with a bearing of north 75 degrees east. Then it flies 648 miles from Cuyahoga to Rosemont with a bearing of north 32 degrees east. Draw a figure that visually represents the problem and find the straight line distance and bearing from Niagara to Rosemont. Alright, so the most difficult part about the word problems or the applications is understanding how to draw the picture. So here we really need to understand bearings. So what do bearings tell us? Well, they're going to give us two cardinal directions with an angle in between. The first cardinal direction is the direction you're going to look. Then the second cardinal direction is the direction you're going to turn. The angle is how far you are going to turn. So, if I start at Niagara and then I go a bearing of north 75 degrees east, that's going to look something like this. So I'm going to call this N, and so north, this is the direction I'm looking, and then I'm turning east. So I went 75 degrees this way. And then that got me to this point here, which was Cuyahoga. So I'm going to call this C, and this was 810. And now from Cuyahoga, you want to draw another little cardinal plane, because the bearings are always based off of this. So here I went north 32 degrees east. So now here again is the north, and I went 32 degrees east. And so I'm going to call this R. And this angle here is 32, and this side is 648. So what are we trying to find? Draw a figure that visually represents the problem and find the straight line distance and bearing from Niagara to Rosemont. So the straight line distance is this. So we want to find that, and we want to find the bearing of that. There are many ways in which we can represent the bearing. The two simplest would be either finding this angle here or finding this angle here. There are other representations as well. So from here, I'm going to let you try to figure out the rest of the problem. So pause the video, unpause when you're ready to check your work. A hint, there's not a lot of work in this, but you are going to use the law of cosines. Okay, so I took the picture, and I knew that if this was 75 degrees, then this here in red was 15 degrees. If I extend this to make a right triangle, I know that this angle up here is 75 degrees, and therefore, if I look at the cardinal axis that I drew up here, this angle is 15 degrees. I know this is 90 degrees, and I know this is 32 degrees. So this entire angle is 90 plus 15 plus 32, or 137 degrees. So that's what I'm calling angle C in my large obtuse triangle here. I want to find the opposite of angle C, or side C, because that's the distance. So C squared is 810 squared plus 648 squared minus 2 times 810 times 648 times the cosine of 137. Type that into my calculator, take the square root, and the distance between Niagara and Rosemont is approximately 1,357.848 miles. Now, we want to find the bearing, and again, there are a lot of different ways in which we can go about writing the bearing. So what I chose to find was this angle here, which I called angle N in that large obtuse triangle. And so the cosine of N is this. Solve using the law of cosines. N is approximately 18.994 degrees. That is not my answer for the bearing. The bearing always, again, needs to be based off of your cardinal coordinate system, so north, south, east, and west. So what I chose to do then was find this angle here in purple. So I know if this is 75, then 75 minus angle N is going to be this angle in purple. Again, I could have found this angle in black as well by doing 15 plus that angle N. Then I would have written my bearing slightly different, but in this case I got 56.006 degrees. So again, answering in a complete sentence, it is 1,357.848 miles from Niagara to Rosemont at a bearing of north 56.006 degrees east. So because I chose that purple angle, I'm doing north 56 degrees east. Had I found this black angle, the bearing would have been east, whatever that number is, and then north. So again, remember, with a bearing, the first cardinal direction is the direction you look. The second cardinal direction is the direction that you turn. Okay, we're running out of time on this video, so we're going to end this one here, and then we'll go on to part 2 for this. There are just a couple more examples for practice, plus we have to do Heron's formula still, but that's just typing things into the calculator. So we're going to end this video here.